Welcome to this podcast episode brought to you by AGS Agriculture Global Solutions, your partner for better farming practices in Malaysia.
It's great to be here.
Usually when we sit down to look at these studies, we're talking about huge, high-tech trials somewhere far away.
Right. Some massive corporate estate with a huge budget.
Exactly. But today, we've got something that feels a lot more like looking over the fence at your neighbor's place.
It really does. We're staying very, very local today.
We're focusing on a field study from Pattani province in southern Thailand. And for everyone listening, especially up in Kedah or Kelantan, you know that Pattani isn't just close on a map.
Environmentally, it's almost a perfect match.
It's a mirror image of what so many of our smallholders are dealing with.
Absolutely. You've got the same monsoon, similar planting materials, and unfortunately, the exact same headaches when it comes to the soil.
And that's the real hook for me. The farmers in this study weren't working with perfect soil. They were fighting typic suffoquat.
Which, I know, sounds like some kind of terrible tropical disease, doesn't it?
It sounds awful,
Yeah.
but for us in the field, we just call it acid sulfate soil.
Yeah.
And if you're a grower, you know this soil. It's the villain of the story.
It really is. It's that heavy marine clay. It's just so difficult. When it's dry, it cracks like concrete.
And when it rains...
Forget about it. It floods instantly because the water just has nowhere to go.
Yeah.
And chemically, it's just naturally incredibly acidic.
So it locks up all the nutrients.
It does. It just makes them unavailable to your palms. It's a real nightmare to farm on.
So our mission today is pretty straightforward. We're looking at how they took this nightmare soil and tried 3 different approaches to fix it, using stuff that, honestly, is mostly seen as waste.
And they're asking that big question, can you stop spending so much money on chemical fertilizer and get better results using what comes out of the mill?
And the answer they found was, well, it was genuinely surprising. It really challenges a lot of what we're told at the agriculture supply shop.
It does.
So let's set the stage. We have 3, let's call them contestants in this study. 3 real farms. I want to paint a picture of them because I think every listener is going to see themselves in one of these approaches.
Yeah, let's break them down.
Okay, contestant number 1. I'm calling this the fish soup approach. This was at the Ban Chamao farm. What were they doing?
This is a classic DIY approach. A lot of smallholders try this. They were using something called fish effluent.
Ah.
You basically take fish, waste heads, guts, all of it, and you ferment it with molasses.
It's that brown liquid you see in the blue plastic drums that has that very distinctive smell.
That is the one. It's a liquid biofertilizer. They were applying it regularly, and they added a bit of urea for an extra nitrogen kick.
And the thinking is you're feeding the microbes, right?
Exactly. You're pouring protein and sugar onto the soil. It's cheap, and it's organic.
Okay, so that's the fish soup. Now, contestant number 2 at Banli Pasango. I think of this as the real-world approach.
I think this is where most of our listeners probably are right now. This farm was using standard NPK chemical fertilizers.
Just like almost everybody else. But they were doing something extra.
They were. They were also applying empty fruit bunch, or EFB, as mulch.
So just to be clear, this was raw EFB, not compost.
No, not composted. They were taking the bunches straight from the mill and just placing them in the weeded circles around the palms.
You know how much?
Yeah, about 6.3 tons per hectare per year. So it's chemicals for the main nutrients and then raw EFB for mulch.
Got it. The combo. And that brings us to contestant number 3 at Ban Bathong, the organic powerhouse.
This one was a commercial-sized plantation, and they went all in on organic. They didn't use raw EFB. They used EFB compost.
So it's already broken down.
Right. Fully processed organic matter.
Right.
And they use that as their main soil treatment. No heavy reliance on chemical salts, just huge amounts of compost.
Okay, so the battle lines are drawn. Liquid fish DIY, the chemical mulch combo, and pure compost, all fighting to fix that nasty acid sulfate soil. I want to start with the chemistry, specifically pH.
The pH is always the biggest hurdle with these soils.
Right, because normally you're buying truckloads of dolomite, of limestone dust to fix acidity. It's a huge cost every year.
And if you don't do it, the pH plummets and your roots just stop working.
So how did our 3 contestants do on the pH test?
Well, this is where we get the first big shock. Let's look at the fish soup farm.
Okay.
They're pouring this fermented liquid on the ground thinking they're healing the soil.
Mm-hmm.
But the data show the pH, it just stayed critically low, around 4.56.
4.56. That is deep in the danger zone.
It is. I mean, at that level, you're losing a huge chunk of any fertilizer you apply because the tree just can't take it up.
So the liquid treatment, even though it's organic, it didn't do anything for the acidity.
It just didn't have the buffering capacity, not enough to make a real difference.
Okay, so the fish soup failed on pH. What about the heavyweights, the EFB farms?
It's a completely different story.
Yeah.
Ban Bathong Farm, the one with the EFB compost, their soil pH jumped to 7.59.
Whoa, hang on a second. 7.59? That's not just neutral. That's actually slightly alkaline.
It is. It's a massive, massive swing. And remember, they didn't add any lime to this field.
None.
None. This change came purely from the organic matter. Even the combo farm, the ones still using some acid-forming chemicals, even they saw a big reduction in acidity just by adding the EFB mulch.
You have to explain this to me because I think a lot of us hear rotting organic matter and we think acidic, like peat. How does a pile of EFB act like limestone?
It all comes down to what's locked inside that bunch.
Yeah.
EFB is packed with what we call basications, things like potassium, calcium, magnesium. But the real key is it's full of organic anions.
Okay, anions, keep it simple for us. What do?
Think of them as acid eaters. Acidity is just an excess of hydrogen protons in your soil. When the EFB breaks down, these organic anions are released, and they literally consume those protons. They neutralize them.
So it's a chemical reaction happening in the soil.
Exactly. It functions as a free liming program. If you're applying EFG in any form, you are liming your soil at the same time.
That is a huge insight for your wallet if you're spending thousands of ringgit on limestone dust every year.
You might be able to cut that way down just by getting your hands on EFB.
And unlike lime, which pretty much just adjusts pH, the EFB is doing double duty.
As a multitasker, it's fixing the pH and it's adding nitrogen, phosphorus, potassium, carbon, everything.
But it wasn't just the chemistry. We have to talk about the physical structure of the soil itself. You said this clay is like concrete in the dry season and a swimming pool in the monsoon.
And that drainage is the other half of the battle.
So the researchers used a term, saturated hydraulic conductivity, or KRS. I'm guessing that's not something you could just measure with a stick in the field.
No, not easily, but the concept is dead simple. It's basically a speed limit. It measures how fast water can move down through the soil to get to the roots.
Okay.
And in these heavy clays, that speed limit is usually, well, it's basically zero. The clay particles are packed so tightly like a stack of plates, water just sits on top.
And that drowns the roots. Root rot.
A disaster,
Oh.
especially come November, December when the rains really hit.
Yeah.
So they measured this KS value. And the farm, using the EFB compost, it had significantly better water movement.
How much better?
10 times better than the fish effluent farm.
10 times. That's the difference between a healthy palm and a drowning one.
It is. And the reason why is purely physical. EFB is bulky, it's fibrous. When you add it to the soil, or even just as a thick mulch on top, you're creating channels and spaces.
You're pushing those tight clay plates apart.
You are. You're taking this dense, hostile clay and, like you said before, making it fluffier.
I like that word, fluffier.
We call it lowering the bulk density. You're aerating the soil. So for any farmer listening who has standing water in their fields for days after a rain, EFB isn't just fertilizer. It's a plumbing renovation.
Which is something a liquid, like the fish soup, can never do. You can't fix soil structure with a liquid.
No, you need mass. You need that bulky carbon material to build things up.
Okay, so EFB wins on pH, it wins on drainage. But now I want to get to the part of the study that actually confused me when I first read it, the microbes.
Ah, yes, the invisible workforce.
I would have put all my money on the fish soup farm for this one. I mean, you're feeding the soy molasses and protein. It sounds like a buffet for bacteria.
And if you just looked at the raw numbers, you'd be right. The data showed that the fish effluent farm had the highest amount of microbial biomass.
So they had the most bugs.
The highest weight of living carbon in the soil, yes.
So they win that round.
You would think so.
Yeah.
But this is the big gotcha of the study, and it's a really important lesson. While that farm had the most microbes, they had lower enzyme activity compared to the EFB farms.
Okay, help me out here. How can you have more workers, but less actual work getting done?
Okay, think of it like this. On the fish soup farm, you fed your crew a diet of pure sugar and energy drinks. That's the molasses.
A sugar rush.
Exactly. They've got tons of energy, they reproduce like crazy, so the population booms, they get fat. But the food is so simple, they don't have to work to digest it.
They don't need to produce any tools.
They don't need to produce complex enzymes to break anything down. They're metabolically lazy,
Lazy microbes.
essentially. But now look at the microbes on the EFB farms. They aren't getting a sugar drink. They're getting cellulose, lignin, tough, fibrous material.
That's a steak dinner compared to a candy bar. It's tough to chew.
It is. So to eat that, they have to manufacture tools. Those tools are the enzymes. So even if the total population is a bit smaller, every single microbe is working hard, pumping out enzymes to break down that tough organic matter.
And those enzymes are what we actually want.
Yes. Because those enzymes don't just break down the EFB. They are what cycle nitrogen, what release phosphorus, what make nutrients available to the palm. They are the engine.
That is such a brilliant distinction because we're always sold products based on microbial count. Contains 10 billion CFUs.
Right.
But this research suggests that the count is useless if they're all lazy. We should be asking about their activity.
That's the key takeaway. You want a hungry, hard-working soil ecosystem, not just a crowded one on a sugar high. The EFB forces the biology to wake up and get to work.
I feel like there's a life lesson in there somewhere, but we'll stick to farming.
Probably for the best.
So we've established that Farm 3, the full EFB compost farm, was the technical winner. Best pH, best drainage, best microbes. But this is a big but.
The logistics, the reality of it.
Exactly. Not every smallholder can generate or afford enough compost to go 100% organic. It's a huge undertaking.
It really is. It's hard to scale that model without a lot of capital. And that's why, for me, Farm Propimba Liposongo is actually the most important part of this whole study for our listeners.
The combo approach.
The combo. Remember, they didn't stop using their NPK. They kept their normal chemical program.
Because it's what they knew, and it works.
It's efficient, it's easy to buy, but they added the EFB as mulch in the weeded circles.
And how did their soil quality stack up against the All-Star Organic Farm?
Amazingly well. Their soil quality index was statistically very, very similar to the full compost farm and miles ahead of the fish effluent farm.
See, that's the aha moment for me. You don't have to be a purist. You don't have to risk your entire yield by going cold turkey on chemicals.
No, not at all.
Yeah.
This is the compromise that works.
Yeah.
You keep your NPK program for that immediate nutrient supply, but you add the EFB mulch on top.
And by doing that, you get the carbon, the moisture retention.
You get that free lime effect we talked about. You build the soil structure over time. It's the best of both worlds.
You get the precision of chemicals with the long-term resilience of organic matter.
That's it. The study specifically mentioned that the organic matter from the mulch significantly boosted carbon and nitrogen retention. It was like a safety net, holding on to the nutrients from the chemical fertilizer so they didn't just wash away.
Okay, let's talk about the waste side of this. EFB is about 21% of a fresh fruit bunch. That's a huge amount of biomass. But I still see it being burned.
Burning is the absolute worst thing you can possibly do.
But it's fast. You get rid of the pile. You get some ash, which has potassium in it.
It's a terrible trade-off. When you burn EFB, you send your organic carbon and all that nitrogen up in smoke. It's just gone forever.
So you're left with a little bit of potash.
You get a quick hit of potassium, sure, but you've destroyed the soil conditioner. You lost the sponge. You're right back to having that concrete swimming pool soil.
And you're throwing money away.
You are. The study pointed out the nutrient savings. EFB is incredibly rich in potassium. The farms using it had high levels of available potassium, even without adding extra MOP.
And MOP is one of the biggest line items on any farmer's budget.
Exactly. If the EFD can replace even half of that, the cost of moving the heavy bunches starts to look a lot more attractive.
It's about closing that loop. You take tons of FFB off the land.
You're removing tons of nutrients. If you don't bring the EFB back, you are mining your own soil. Eventually, that bank account runs dry.
So let's make this really practical. I'm a smallholder. I'm listening to this. What are the exact steps I should take tomorrow based on this study?
Step 1. If you can get EFB, get it. Don't let it be burned. Get it back to your field.
Okay, I've got a lorry load of EFB. Where does it go? Not just scattered everywhere.
No. The study was very clear on this. Mulch the weeded circle.
Right around the base of the palm.
Yes. Don't waste it in the interrows for the weeds. Put it where the feeder roots are concentrated. That's where you need the moisture. That's where you want that pH buffering.
And what about the amount? The study said 6.3 tons per hectare per year.
That's a good target. If you break it down, that's roughly 40 to 50 kilograms per palm each year, depending on your density.
So 4 or 5 bunches per tree.
Yeah, that sounds about right. It's very manageable. You don't have to do it all in one go. Just make it part of your routine.
Okay, what's the timeline? I put down fertilizer. I see the leaves get greener in a few weeks. What about EFB?
And that's the crucial thing. You need to be patient. The nutrient payoff, especially the potassium, That's pretty quick as it breaks down.
But the structural change.
Fixing that heavy clay, improving the drainage, that takes time. The study showed the big changes in soil texture took about 2 to 3 years to really show up in the data.
So it's a long-term investment in your land, not just a quick fix for the next harvest.
Exactly.
Huh.
But it's an investment that pays off. The soil quality index for the fish soup farm was 0.65. The EFB farms were up around 0.80. That's a huge, measurable jump in the health and productivity of your land.
And a healthier soil means a more resilient palm. Less stress in a drought, less disease in the wet season.
It creates a buffer. And with our climate becoming more and more unpredictable, that resilience is just as important as the yield numbers.
This has been a real eye-opener. It's good to know that all that hard work of moving EFB isn't just busy work. It really is free fertilizer, free lime, and a soil conditioner all in one heavy package.
It is. And for any Malaysian smallholder on these kinds of acidic clay soils, this study is a roadmap. The solution isn't some fancy imported product. It's sitting right there at the mill, waiting to be used.
Before we go, there's one thought I want to leave our listeners with. We talked about how the fish effluent created those lazy microbes. It really makes you wonder how many other quick fix liquid fertilizers are doing the exact same thing.
It's a pretty disturbing thought, isn't it?
It is. Are we feeding our soil a diet of candy when what it really needs is a proper, tough steak dinner to get strong?
That's a fantastic question. It suggests we need to evaluate our inputs not just by the NPK on the label, but by the kind of biological behavior they encourage underground.
Are we building a resilient workforce or just a temporary crowd?
A temporary crowd of freeloaders. That's a good way to put it. Something to think about the next time someone tries to sell you a miracle in a bottle.
Remember to visit our AI farming assistant at propdrive.ai to learn more on how to increase your oil palm yields and incomes. Thanks for listening.